Okay, here comes a question about units. What is the unit of electrical potential difference expressed in fundamental SI units? It's a quite tricky question, but also quite common question to ask for units. And the first thing you need to be aware of is that in physics we are very accurate with definitions. So electric potential needs to have the same unit as gravitational potential or any other thing. So it doesn't matter which potential they are asking for, they need to have the same unit. And difference, if you take a difference between two values, you will have the same unit. So if you have the difference in height is measured in meter, you know that, and height is measured in meters. So it doesn't matter the word difference. Electric potential, this is how you probably started. You need to know something about potential. We use the symbol V for the quantity of electric potential. Do you know the definition for electric potential? Well, that is the work you are doing on a charge moving from two places. Then you have the difference actually. Now, to be able to find the SI units, can you find how we define work in some way? You can start by F times S, for instance. So we're doing this a couple of steps now. And a charge is actually defined as the current passing through an intersection multiplied by the time you are multiplying it with. So this is how you can write it. And we need to do this because we need to find units for different things. Probably you don't know the unit for work. It's easier to know units for more and more fundamental stuff. So force is more fundamental than work because work is made up of force and something else, the distance that the object is moving. Or you can do it like this. Force could also be written as m times j. That is the gravitational force of an object close to the surface of the Earth. And the distance that it's moving or the displacement could also be the height that you are moving it. So m is more fundamental than force because you're using m and g to get the force divided by I times t, the current multiplied by the time. Now, I'm doing this because we want to find the SI units for electric potential difference. And the unit for that needs to be the same thing as the unit for these. And it's quite easy to know the unit for mass and the gravity field strength and height and so on. It's harder to know the units for work and charge immediately. So let me show you now. Normally when I'm working with units in my class, I use brackets to understand it. It's not a quantity, but it's unit. It's really tricky here with electric potential. You have the same symbol for the quantity of electric potential as the unit for electric potential. It's probably the only quantity in units that have the same symbol. That is tricky. Is equals to. So this needs to have the same unit as this. Can you finish this exercise? You can take a pause in this video and try to do it by finding the unit of these individual things. And then start the video again. Now, the unit for mass, that is in kilogram, multiplied with the units for the gravity field strength. Well, you know also that this is an acceleration. It's 9.81 if we talk about the close to the surface of the Earth. So that is an acceleration, and acceleration is mass per square second times the unit for height or displacement. H again, shouldn't be. It's in meter. We are measuring distance in meters. Sorry for that. Current. The SI unit for currents is in ampere. Multiplied with the unit for time, that's in second again. Brackets, so we understand that this is unit we are working with, not quantities for anything. Now let's fix this so it looks beautiful and on one line. So we start by kilogram multiplied by m times m, that's m squared, multiplied by per square second divided by second, that is s minus 3, or per cubic second, multiplied by a to the power of -1 and a bracket around it. And these are all SI units: kilogram, meter, seconds, and amp. And luckily as we are, that is also the option C here. Therefore, C is the correct answer. Thank you and goodbye.